Hi guys, we are going to be working with fractions today and specifically with modeling what it looks like to share things equally. So you've already learned a lot about fractions. You've learned the numerator is the top number, the denominator is the bottom number. You've learned that the pieces have to be equal and how to name them using a numerator and denominator. And so today we're going to draw some pictures to show how we could represent some problems like word problems and come up with a fractional answer. Okay, so I'm going to give us a problem. If we had two brothers that go to lunch and they're sharing 3 8-inch pizzas, how much will each brother get? So if we take what we know there's two brothers, right? So we've got 2 brothers, all right? And we know that they're sharing 3 8-inch pizzas. So I've got 1, 2, 3 pizzas. So what we're going to look at is multiple ways that we can share those pizzas with those 2 brothers. So first of all, I want to ask myself, is there enough for each person to have 1 whole? In this case, there is, right? This brother could eat this pizza and this brother could eat that pizza. So they each have enough to have a whole, but there's 1 left over that they need to share. So if we think about who they're sharing it with, that would be the denominator, right? You're sharing it with 2 people. So if we split that pizza in half, each brother will get 1 extra half. So this half will go to this brother, and this half can go to this brother. So then, if we look at our picture, we can tell each brother got 1 whole pizza. Should I do that in black so it stays clear? They got 1 whole pizza, and then they also get a half a pizza. So you could say this brother got to eat 1 1/2 pieces of the pizza. But is that the only way to show this picture? I don't think so. So let's take a look on the other side. What if we still have, let me get over here so you could see it. What if we still have those same 2 brothers, and they're still sharing 3 pizzas, but they can't decide who's going to get that whole pizza. Can they split these pizzas and still share them? Absolutely. So if we split half a pizza, half a pizza, half a pizza, if we split all of them, let's say they're all different flavors and they don't want to eat a whole one, or they both want to have some of this, we can share it in half, right? So each one of these pieces that we made, we can label, they're all halves. But we still have the same question. How much pizza does each brother get? Well, we can still share them evenly, right? This brother gets 1 piece, 1 piece, and 1 piece of each pizza. And we could say the other brother gets this half or this piece, this half or this piece, and this half or that piece. So each one of those brothers would get 3 halves. So if I added that together, I would have 1 half, 2 half, 3 halves. So each brother then gets 3 halves of the pizza. So let's take a look at that. This answer is 3 halves. This answer is 1 1/2. Is one of them wrong? I don't think they are. So let's take a look and see if we're representing the same amount. So this was 1 whole and a half, 1 1/2. This was 3 halves. Well, what do we know about 1 whole? How many halves does it take to make 1 whole? 1 half, 2 halves. So if I have 2 halves here, and then I have a 1/3 half, wouldn't that be the same as 3 1/2? So even though my number looks different, 3 halves, 1 1/2, it's still the same amount of pizza, and there's 2 different ways to do it. Could we come up with more ways to split the pizza and share it evenly with 2 brothers? We sure could. We could cut it differently, but we have 2 different representations of the same problem. So let's try another one. Let's get rid of this. Let's try another opportunity to share some things. Most that red off of there. How about this time? Get my markers ready here. How about this time we have 6 hikers? Make some notes. We have 6 hikers going out on a trail, and they're going to bring with them 4 pounds, LBS is abbreviation for pounds, of trail mix. Can we show a picture to represent how we would share this? Let's see. We've got 6 hikers. 1, 2, 3, 4. Let's keep going. 5 and 6. Here's our 6 hikers. And they're going to share 4 pounds of trail mix. 1, 2, 3, 4. Now, in this example, is there enough for each hiker to have their own pound or bag of trail mix? 1, 2, 3, 4. Nope, because you'd have 2 hikers left over that don't have any, right? So how can we divide this to share them equally? There's going to be more than one way to do this. First of all, I see 6 hikers. So if each hiker got 1/6 of the bag, so if I break it into halves, I know 3 plus 3 is 6. So if I break this into 6 even squares, I know that I could give each hiker one of those squares, right? So if I'm giving this one to the first hiker, what fraction would we call that? We've shaded 1 out of 6. So he gets 1/6 of this first one. But then he also gets 1/6 of this one. He also gets 1/6 of this one. And he gets 1/6 of the last one. So he ends up getting a piece of all 4 of them. So we've got 1/6, 2/6, 3/6, 4/6. And we could say the same for each of the other hikers that follow. So altogether, this guy got 4/6 of the trail mix. But is that the only way to show the picture? Of course not. We could divide it in other ways too. So what if we took, we could do circles this time too. What if we took those 4 pounds of trail mix, and let's think about some numbers that are related. So I know 6 is double 3, right? 3 and 3 together would make 6. So what if I did 3 and 3 together to make 6, 3 and 3 together to make 6? So if I split this into thirds, 3 and 3 together makes 6. So then I could have 1, 2, 3, 4, 5, 6 hikers could each get a piece. And it's even, so I could repeat that again. So I could have 1, 2, 3 hikers, 4, 5, 6 hikers, each one would get a piece. So if I'm hiker number 1, I'm going to get this piece, and I'm going to get this piece because I'm hiker number 1. Okay? So let's look at what that means. What would you name this fraction that we colored right here? It is 1 piece out of 1, 2, 3 in the whole, so it's 1/3, right? So I got 1/3 of this bag, but I also got 1/3 of this bag. So altogether, I got 1 2/3. Let's put it down here so we can see it next to the other one. Okay, so in this picture, I got 2/3 of the trail mix. In this picture, I got 4/6 of the trail mix. So let's think about what that might look like. Let's go back to this picture here. If I have 2/3 of something, I have 1, 2, it would look something like that. Now, if I think about it as 6, which I drew this in a rectangle, but I could also draw it in a circle. So let's draw it in a circle. If I had 6, I would start with thirds, and then I'd just cut them in half again, right? Because 3 plus 3 is 6. So I would take each one of my thirds and split them in half. So now I have 1, 2, 3, 4, 5, 6 of them, if I color in 4 of those 6s, which is what I did up there with my rectangles, I would color in 1, 2, 3, 4. Notice anything about my fractions? Whether I called it 2/3 or whether I called it 4/6, it means the same thing, right? So let's take a look at those numbers. Do you see any patterns? 2 to 4, 3 to 6. Do you see how they were both times 2, times 2? Okay. When you start to have patterns like that, that's how you will start to recognize equivalent fractions. And I'll tell you why. Are you ready for this? If this was a fraction, we multiplied times 2 and times 2. What's 2 halves? 1/2, 2 halves equals 1 whole, right? Don't you already know that any number times 1 is that number? It works in fractions too. So you have 2/3, you times it by 1, in this case we use 2 halves, that's 1, right? We agree? 1. And even though you call it 4/6, it's still the same thing. So it works with any number. It works with 3/3 or 4/4. As long as it's representing 1 whole, it'll be an equivalent fraction. So you could come up with a whole list of equivalent or equal fractions. That's just a side note. Just something a little extra for you. So your job today is you are going to be working on some of these picture representations in your math journal. So you're going to start on page 68 and do the same thing that I did. Draw some pictures, draw some circles, draw some rectangles, divide some things up, and see if you can come up with two different ways to solve the same problem like we did on here. Feel free to watch the video again, whatever you need, and ask questions. Thanks, guys.